So this is the result that we have, and if I rewrite it like this, you can see that it has a commutator form easily. But I'm just going to keep it on one line because we're going to have a lot of lines of work ahead. Just like with the standard algorithm, our goal is to move all three 1x3 blocks into the right slice. That way we can apply a quarter turn, and then we'll put back two 1x3 blocks worth of pieces and pull out an extra 1x3 block, leaving us with the net result of just two 1x3 block pieces out of place. This 1x3 block here is by itself, while this one here and this 1x3 block, they're intersecting. This one and this one are intersecting. Since they're intersecting and they're in the right slice and this one's by itself, how about we take this one that's by itself and put it in the right slice with the other two, so that all three are in the right slice. In order to do this, we can apply the setup move L prime. We can see that the 1x3 block was moved up into the upper layer slice, and these two remained here. Now what we need to do is another setup move U2 to put this 1x3 block into the slot right here in the right slice. That will be connected with this 1x3 block and in fact be what we need. Applying that to the cube, that 1x3 block moves there. Like these two 1x3 blocks, this 1x3 block here and this 1x3 block here, they're connected perfectly as in appearing to be solved. So all we have to do is apply a quarter turn, in this case R prime. That will put back these two 1x3 blocks, leaving us with what we need, an interior looking J part. And as I poured out in the standard algorithm video, it's two 1x2 center blocks swapped and two individual edge cubies. Adding that in, now we're ready to move on. We're going to apply this technique shifting again to this algorithm. Before I do, I'm going to put it on one line so that we can easily see which moves were shifted. What we need to do is shift backwards, as in move R prime, from the last move and make it the first move. Now, one thing to mention first is that what is really a shift? Is it justified as a logical fix? If we take back this, remember what we had. We had an R prime in front from the shift. Let's say I want to say add the setup move R prime. What I'm going to do is I'm going to invert it at the end. When that happens, this R and this R prime will cancel, which leaves us with that. So essentially a shift backwards of a move is the same as doing the setup move with that move, if that makes any sense at all. If we just rotate the cube this way, like this, we'll have an identical setup to the standard algorithm from the point where we start to add the last setup moves to finish off the main piece of the algorithm. Notice now that this 1x2 center block affected is down here, which is really in the F phase. I'm just rotating the cube down. This 1x4 block here needs to be moved into the 1x4 slot up there. So with the standard algorithm, from this point, if we pretend that this cube is just how it is and that this is the upper face and this is the front face, we did the setup move F2. That moved this 1x4 block here by first moving this into the slot which is affected, and then when we undo it, it's moved there. From there, we did one more setup move to move this 1x4 block up there so that these two individual edge cubies are swapped oppositely, and this center are swapped diagonally. So moving the cube back to the way we have it, the idea is to separate this 1x4 block from this. So if we wish in our minds that we want this 1x4 block here, what we can do is we can just shift it. We can shift the last move and that will give us that result. So if I take U2 and I shift backwards actually, because I'm going to move the last move to the front, applying to the cube, indeed it moves over with no problems. If we go back to what we had and I add in a setup move U2 and I undo it at the end, these two U2s will cancel, leaving us with the U2 in front. which is equivalent to shifting it. So one cool thing about a shift is if you want to shift in a regular direction, let's say that I want to move this 1x4 block here. I wish I could do it in the same number of moves that I currently have, so how do I do that? If your algorithm's first move involves that piece you want to move, then if you move it to the end, it moves with it. Anyway, undoing that and moving that back, the last thing we need to do, well, this, again, if we hold this at the bottom, for the standard algorithm, this 1x4 block needs to move into the 1x4 slot up here. So normally we would do the setup move L and then invert it with L prime, but here we can just take this and shift it backwards. By doing that, it gives us what we want. The same setup as a standard algorithm. In the standard algorithm, in order to make it a pure edge flip from this setup, we applied outermost setup moves R2 and B2. But in this case, that's not R2, B2, because we're just moving the cube like this. It's R2, D2, because the D2 is down here. But at the same time, we can also do R2, F2 if we wanted to. R2, F2 will give us a pure edge flip as well, just in a different location, but that's fine. In this case, it's not F2 that we're actually rotating, it's U2. So the setup moves that we need to do from this point to make it a pure edge flip algorithm, and it doesn't matter where the edge is because we can move it later, is do R2, U2 as setup moves. Okay? So this is what we have, and it flips the bottom back edge back there. So now what I'm going to do is transform this a little bit so that that edge is moved here and at the same time it's more user friendly to execute. So writing on one line, doing a move cancellation between this U and this U2, which becomes a U prime. Rotating the whole thing about Y2, that will move the edge into the bottom front slot. And if we take the mirror, then we have a more user-friendly algorithm to perform. Next, by experimentation, the following moves can be made wide and we still have a pure algorithm. I'm going to apply this to the cube before I move on. As you can see, the center affected is in F and the edge affected is here. Now, adding an interior X cube rotation for easier execution, or that was a LW and F2. If we just made that LWX, that will become a U2. And then we're going to have to invert that X cube rotation before we get to the next face turn. Now, conveniently, we can convert the LWX to RW on the 4x4. Now get rid of that X cube rotation and give us all U2s for this portion of the algorithm, which is pretty neat. Finally, if we add in the setup move X prime so that we affect the edge in the top front position, then we have something that's much more useful for us. Applying this to the cube, the center affected is now the top and the edge affected is here. So that is indeed the algorithm which we needed to derive from the beginning.